Hello everyone, this is Dr. Song. Welcome to my YouTube video. So today we will explain about, we will study a bit more about the JET scores. So these are the resources. I took the references from the courses and I made my course based on those courses. So this is the references. And then let's start with this practice. So we learned about what JET score is, and then now we have this stage of practice. So you can see here there is a data distribution, and then this is the mean score. That is a 70.2, and then the standard deviation is 11.55. So in fact, the question is here, the first one. What percentage ended up with the 60% or lower? So 60% is here, and then so 60, the grade of 60, and that is lower than a 60. So you can transform the X into a Z score. So the 60, that is the physical grade is a 60, and then minus 70.2, that is about the mean score of this data. And then you can divide by the 11.55, that's the standard deviation. So this is a like the how can I say that, is a formulation how you will obtain the Z score of the 60, grade 60, that is a minus 0.88. Okay, so that is the Z score. So when you see your Z scores table, you will find that is corresponding to minus 0.88. That is the 0.1894. That means that is slightly about a 19. So we can say that under the 19% of all students, they have the lower than the 60, the grade of 60. So this is how the Z score functions in the data distribution. We can see another example here. What is the grades of the best 10% look like? So what is the score? We can consider that is the best 10% of this data distribution. So again, you can take a look about the Z score. That means that is a 10%, about the 10% that is in the Z score table indicates that Z equal 1.28. So you put the 1.28 in the end, and then we don't know what grade can represent the 10%, and the minus 70.2, that is the average score, divided by 11.55, that is the standard deviation, and we can obtain that is like algebra, you can obtain the x is 85. So this means that is greater than 85, the grade, we can consider they are the best 10% of this data distribution. So this is the practical way how you will calculate about the percentage and the Z score, and then the grade. Okay, yeah. So this one again. Let's say the weight of the cats are normally distributed with a mean. So that is average is 10, and the standard deviation is 1.5. Yeah. So Mr. Whisker's weight is 13 pounds. So this is individual score. And what the Z score is associated with this weight. So this means that if somebody is if one cat is 13 pounds in the data distribution here, where that is situated. So the Z score means that that's 13 pounds, where is it situated? Yeah, so to calculate this, you can do here 13, that is the weight, minus 10, that is the mean, and then divided by 1.5, that is 2. So the Z score is 2. Z score 2 means that here is around here, that the standard deviation is 1, and then 2 and the 3, that is 2. So that is the zone, standard deviation zone, is about the 2.5% of cats weight or more. So you can see that when it's a data distribution, is here is about 95% of the zone second. That means that here what is remaining is 2.5%. Yeah, is a 2.5%. And then the other side is also 2.5%. So they are together is a 5%. So this one and this one. Yeah. So you can say here is a 2.3 or 2.5%, Why? Because that is the only this part you calculate. You don't consider this one. That's why you can say that 2.5% is more than the this cat. Okay. What percentage of cats weigh more than whiskers? That is yeah, 2.5%. And then only 16% of cats weigh less than a ginger. Only 16%. What jet score is? So when you go to the your jet score table, that is a 16%. You can find it that there is one. So that is means that is a standard deviation was the like for instance this is zone one and then zone 2, that is a standard deviation 1, and then standard deviation 2, and then that score is 1 means that is here. So that is the 1. So you can say that it's associated with this percentage is a 3.5%. Why? Because there is about 30, yeah, 34%. Because the standard deviation 1, that is the about 34%. Yeah, so that's why you can say like that. And then how much does ginger pound? That is we don't know the how much is the pound, and the minus 10, that is the average, and then divided by standard deviation is 1. So that is 1 is 11.5 points. So you can calculate that with the x with this formula like algebra. Yeah. So the x was 11.5. Now let's see another example. So here, in fact, that is French, but the basically what it means that the probability of to find that one person has the greater than the IQ is 125. So this is simply you will obtain the you will use the same formula. So the individual score we don't know. No, in fact we know there is 125, and then the average is 100, and the standard deviation is 15. So in that case, you can obtain the 1.66. So when you find the 1.66 Z score in the Z score table, that will indicate that that is here. Yeah, there is a Z score table. You will see that that is the 0.0485. So that means that here is about 10%. So that is a one zero virgul uh, 0.1. So that is the jet score. So that means that is about the 10%. So here you can say that the answer will be about the 10% of this data distribution. You will find the greater than 125 as a IQ. So and then this one is the about I calculated that where is the standard deviation 2 zone. So that's why I put the 2 here. And then we can see that there is 130. That is about 2.5% that remains here. So it's about 97.5%. So that is under 130. And then from the 130, we will consider that there is about 2.5%. The people they will have the greater than 130. So this is the way how you will calculate the Z-score table. And then in fact, the very important to see the how you can interpret 1.66, that is Z-score. And then you can see that that is which remains this part about this part, yeah, in the upper part. So that is the 0.0485. So that is about approximately 5%. Yeah. So if that is a 5% here, is not a 22.5, is a 5% here. That is another side is also 5%. 5 plus 5 is a 10%, which that means that about the 90% of the area here, yeah. And then you can say that that is a p-value. That is the is a p is a equal is a 0.21. So this is about the 10%. So you can say that p-value probability is about 0.1%. Okay, so this is what I'm explaining here about the greater than the 125, the IQ, that will be the p-value is about 0.1, and means about the 10% of the data distribution. Okay, so again, yeah, so whenever you make the the percentage of the what is the p-value here, that will be, this is about the 2.5%, and then this will be also 2.5%. So the about the two tails, it will be the 0.05%. 0.05 means the 5%. So already you have to consider the two tails. You not only this one, but also the minus part. So both of them you have to add to make the p-value with the two tails. And then also we can think about the confidence intervals. So what is the confidence intervals? So when you obtain the one score, in the margin of error, it can be the error area. You will make the mark with this mark like that. So that is the like how much margin you can consider, that is like error area. So when this error area is they are overlapped, like this one, for instance, like this one, and then we consider that it's the same. Yeah, even though they are slightly less, but if there is the margin of error area is they are overlapped like this, and then we can consider that this the smaller one and the greater one, we cannot say that is different, they are same. So this is about the concept of a margin of error. And when you obtain the margin of error, this is a formula. So there is a score plus, and then z score, and then you are multiply by the standard error. So this is the formula about the standard error. So you will obtain the standard error z score, that is depending on the what you want to put. If we want to put the 10% will be the 0.1, and then it will be the second one will be the 0.2, and then that third area is about the extremely small amount. So this one will be the z score will be 1.66, and then this standard deviation 2, that will be the 1.96, and then standard deviation 3, that will be the 2.58. So this one is the z score. These are the z score. Yeah. So these are the z score. And then, okay, so this is 1, and this is will be the 0.5. Yeah. And then this will, again will be the 0.01. This is the p-value. Yeah. So this is the p-value. So you will multiply, you will do a plus minus and then the z score multiply by the standard error. Okay, so this one I have to explain more in the next session. Today we will more focus on about how you obtain the z score. I showed you that is about these two practices. So this one and then this one. Yeah. So please review what I explained about the z scores, how you can practice with the exercise, and then we will do the next step about the confidence interval. So thank you so much for your watching. And then if you have any comments, please write the comments in this video. I think that I will improve the part. Maybe I didn't explain very well. So that is very important. So please write your comments. Thank you so much. See you next time.